Okay, for 15a part 1, okay, 15a part 1, for each of the graphs shown below, write down a possible equation for it. Okay, now first and foremost, right here is 1, 1. Let me just demonstrate something to you. I shall use my orange pen. 1, 1, it's like this, 1, 1. So if I were to draw a line like this, 1, 1, okay, 1 and 1, this line will actually be y equals to negative x. Notice that this gradient over here for question 15, okay, this gradient is actually less steep than y equals to negative x. So any possible values below negative 1 is, between 0 and negative 1 is possible. Less steep means that your gradient could be something like negative half, negative 3/4. Any of these values are accepted, but in this case, I will say that y is equals to negative half x. But notice, for negative half x will actually pass through my origin over here. Okay, negative half x will be something like this. Okay, it passes through the origin, but over here you can see that the line is actually translated downwards. So any possible values here, so in this case it looks slightly about negative 1. So I'll say that here it is negative half x minus 1, which is a possible answer. There are many possible answers for 15a part 1, but this is one possible answer. So I write it down here, y equals to negative half x minus 1. Okay, for 15a part 2, we have this graph over here. First, you notice that this is a to the power of negative x graph. Okay, but a to the power of negative x, normally what you get is down here, like this. Okay, then the asymptote is y equals to 0. This is y equals to a to the power of negative x. But in this case, you notice that the entire graph is translated, or it moves upwards. So here it must be a value that is greater than plus 1. So in this case, right, you notice plus 1, you'll probably shift up here. So here a possible value is y equals to a to the power of negative x plus 2. So that is a possible answer there, but I'll just take it as plus 2. If you rotate it as plus 3, plus 4, plus 5, fair enough. Okay, but it cannot be less than plus 1. This plus 1, the asymptote will actually be down here. In this case, it's shifted even above that. So a fair value is y equals to a to the power of negative x plus 2. Oops, you can see it working there. Okay, B part 1. Express the y equals to x squared minus 3x minus 1 in the completed square form. Okay, so first x squared minus 3x minus 1. Okay, so now what I do, x minus 3 over 2 square minus 9 over 4 minus 1. So in completed square form, okay, then maybe in the other methods you may employ to get the completed square form, but this is a method that you should be well aware of by now, okay, or whatever method that you choose to use. Okay, it's minus 13 over 4. So what we have gotten is the completed square form. The completed square form will actually give you the turning point of the graph. In this case, you notice that the coefficient of x squared is positive, so it's a smiley graph. Alright, so the minimum point we write down is equals to 1.5, and here is negative 13 and 1/4 is negative 3 and 1/4. Straight away from the completed square form, we are able to get the minimum point of the graph. Next thing also, what we want to find is the y-intercept. So to find the y-intercept, let me just draw a line there. For the y-intercept, the x value is 0. So let x equals to 0. So y equals to 0 square minus 3 times 0 minus 1. Y is equals to negative 1. So therefore my y-intercept is at negative 1. We can begin sketching the graph. we begin sketching the graph, it is, as I have explained earlier, okay, it is a smiley graph. So we sketch. Okay, label the minimum point here. The minimum point here is 1.5, -3, and 1/4. Alright, and this point here, it should be -1. Okay, my scaling's a bit off, but it is somewhere there. And this is the graph of y equals to x squared minus 3x minus 1. I forgot to fill in this part here. Y equals to x minus 1.5 square minus 3 and 1/4. And that concludes question 15b.